Welcome, everybody. Thank you for joining us. My name is Dusty Lang. I am the director of the DHS SBIR program, and we're happy to be bringing you the latest episode of the Deconstructing SBIR webinar series. I always like to give an overview, very high level, of the SBIR program for folks that may not be familiar with it. But I will say that we're only able to do a high level overview today. We do have another webinar that we'll put a link into the chat for another series, our Insights Outreach, where we went into the program in depth. So you can go back and watch that one later if you need more information on the program. But generally, the SBIR program was established by Congress in 1982, and the goal of the program was for the federal government to be able to partner with innovative small companies to take advantage of the agility and their entrepreneurial spirit that they bring to finding different and unique solutions to our challenges. The program is a three-phase program. It starts with the phase one, where we go out with the topics through a solicitation and ask you to submit proposals that'll help for us to understand the concept that you're proposing and how you would prove that feasibility or the proof of that concept. From there, any phase one awardee is eligible to compete to receive a phase two award for a prototype development and demonstration. So we're looking for you to be able to say, okay, that concept was great, and now we're going to develop a prototype for those capabilities and demonstrate that that is possible. And then the third phase is often called commercialization, but the good news is that, even if we haven't been able to get all the way fully developed in the phase two, there is potential that if additional funding is found through other parts of the organization, non-SBIR funding, you can get a phase three to do further research and development or test and evaluation as well. Anything that's non-SBIR is that phase three. There's more good news. So any SBIR award comes with automatically the SBIR data rights. So as a small business participating in the program, you would be owner for any data that is developed under that effort and that award, including the intellectual property. And then another bit of good news is that the government can do a directed award to an SBIR awardee for the technology that they developed under a previous SBIR. It just has to derive from, extend, or complete that prior work. So, as I said, we're here today to actually talk not about the program in general, but sort of a take on that last bit where we can go forward with technology that's been developed under a previous SBIR. So under the SBIR program, all of the federal agencies are eligible to leverage that development, that award that has been conducted and awarded by another federal agency. And at the DHS SBIR program, we in 2015 decided that we were going to go ahead and make sure that we were able to leverage that. So we purposely put in effect an other agency technology solutions program, or OATS. And this program is where we take a technology, an SBIR award or STTR award that has been begun at another federal agency, and we think we might be able to do some further development for that and be able to use it at DHS. Traditionally, that's been done via regular market research. We happen to come upon an SBIR award, or it's been through chance interactions with other federal agencies or small businesses at conferences or other events. But recently, we've decided that we want to kind of give these small businesses to do what they do best yet again and be innovative. So we've decided we're going to go out with RFIs, requests for information, to the SBIR awardee community to see how they may be able to use the technologies they initiated out of the federal agencies to help solve some challenges that we still have at DHS. So that is why we're here today to talk about the Remote Small Space Unmanned System RFI. And to be able to do this best, I would like to introduce some colleagues so that they can help me go through some of these questions that I don't know the answer for, and perhaps you do not as well. So I have Dennis Gusty, who is a portfolio manager at DHS S&T. DHS, the Department of Homeland Security, and S&T is Science and Technology. So welcome, Dennis. And I also have Fred Endicott, who is FEMA USAR, and the USAR stands for Urban Search and Rescue. So if you guys could introduce yourselves and let the audience know what you do in your job.
Okay, thanks, Dusty. As you said, I am the portfolio manager at DHS Science and Technology Directorate. And so what is a portfolio manager, right? So all the projects that I manage or oversee are in support of FEMA, one of the DHS components.
Thank you. Fred?
Thanks, Dusty, and good afternoon, everybody. I'm Fred Endercat, Chief of the Urban Search and Rescue Branch at FEMA headquarters. I have responsibility for the program that manages 28 of our federal urban search and rescue task forces across the country. It's comprised of about 6,000 personnel. Previously, I was with the Philadelphia Fire Department for 36 years, serving in a very similar parallel positions. And for 20 of those years, I was also a member of the Federal Urban Search and Rescue System as a member of Pennsylvania Task Force 1. Thanks, Dusty.
Thank you both for joining me. And you guys can stay on camera so that the audience can see your wonderful faces. And Dennis, thank you for dressing up for us. That's very nice. I like your tie. So
I only do it for you, Dusty.
I know better. So can you describe for me the relationship between S&T? You touched on it very briefly, Dennis, but so the relationship between S&T and how we partner and work with FEMA?
Sure. So Science and Technology is the research and development arm of Homeland Security. So our mission is to enable effective, efficient, secure operations across all Homeland Security missions by applying scientific, engineering, analytic, and innovative approaches to deliver timely solutions and support department acquisitions. And how do we do that? So we conduct basic and applied research, development, and demonstration, testing and evaluation activities relevant to all the missions within DHS. And so our stakeholders include all the components, emergency managers, industry, manufacturers, non-governmental organizations, training officers and associations, procurement officials, grant issuers, standards bodies, regulators, and international partners. So in this case, FEMA is one of our partners, and as a portfolio manager, it's my responsibility to gather any gaps or requirements they have in order for them to achieve their mission and help resolve or come up with a solution. So this is one area or one way of us supporting our component, in this case, FEMA. Thank you.
Thanks, Dennis. Fred, I want to just say I do like your shirt as well. So I wanted to make sure we were on board that everybody was looking lovely today.
Thank you. Maybe at the break, I'll go put a tie on to match Dennis.
Thanks. I went for the more casual look myself as well. I did not wear the suit and tie. So one of the things, Fred, is that the USAR team is called out to respond to scenarios and situations where you don't know what you're going to face. And so I'm sure that there's lots and lots of those challenges out there, and we're always perhaps finding new ways to try to delve into a solution that may be able to help us be able to respond to those scenarios better. Can you tell me about the impetus for this RFI? Because I know that was part of the interaction that Dennis was just referring to.
Sure, Dusty. So really, the most recent impetus, the driver for this one currently, was the response to the collapse in the Surfside, Florida, the condominium collapse last June. But there's a lot of parallels to previous large-scale disasters we've gone to that are similar in challenges presented to rescuers. A couple that come to mind: the World Trade Center collapse after the September 11th attack, the Haiti earthquake, and then going back to 1995, the bombing of the federal building, the Murrah Federal Building in Oklahoma City. So they all present, very similar challenges. And we're really looking for solutions for the past 20 plus years on how we can do things a little differently and more effectively. You know, a lot of times when we show up on a disaster site, particularly with this type of building construction, steel frame, reinforced concrete, it's almost insurmountable odds that we're facing. And you know, time is really our enemy in rescue operations. So the quicker that we can positively confirm the location of buried survivors, the faster we can get them out. And the more time that we take to do that, to locate them and accurately find where they're at and what they're entrapped in, the harder it is for us to successfully rescue them. You know, we've been aiming for many years to detect potential survivors by subterranean remote search of rubble piles, particularly in pancake collapses and other confined spaces. And the challenge is, again, time and technology for us. Thanks.
Yeah, I mean, and you know, the 20 years, you know, it's not, we've made advances, but you know, again, we're always looking for how we can do better. And clearly this is a place where we'd always love to have the optimal results. Can you tell me a little bit about, in that vein, what technologies we've come to use over the years and where we still feel like there's some lacking or some opportunities for improvement?
Sure. So just starting with the options that we have in front of us as first responders or technical rescuers. And, you know, usually we start out with physical search operations, not a lot of technology there, right? Just the first responders, usually firefighters, eventually USAR teams that come in and physically go into void spaces, remove debris, and search for victims. Taking it up a notch, but again, not really on a technology side, is canine search operations. And we utilize live find canine search teams to help us definitively locate where people would be buried under the rubble. And then on the technical search side of the house, really two main tools that we use right now, and you'll see illustrated on the slide that's on the screen, technical search cameras. And the first image on the left is from the earthquake in Haiti. And what you see there is that after the concrete void space has been expanded, it's been opened up, and you can see the steel rebar cut, and a hole is bored, a 2-inch hole is bored to allow the search camera borescope to go down into that void space. That camera has an articulating feature on it. It can, you know, maneuver 360 degrees and give the operator a really clear picture of what's beneath that rubble, and it'll show how victims are entrapped and what we need to do to remove them, what other rescue technology and techniques we need. If you look at the image on the right, 11 years later, this is the Surfside condominium collapse. Same tool, a few upgrades to it, you know, color cameras. Now, when we first started with these 20 years ago, they were just black and white cameras. They didn't really have that articulating capability. But, you know, we rely on these tools extensively for this type of work. So those are, you know, that is one, right? And then the other is a seismic and acoustic listening devices that use usually a series of 6 sensors that are placed across the rubble pile in very targeted areas and then triangulated. And hopefully, you know, by hearing some sounds, we can zero in on the location of a buried survivor. So those are the two main technologies that use now. We also have graduated a little bit with geotagging and some structural engineering. So at Surfside, we used geotagging with structural engineering calculations and very detailed interviews of survivors to try to tell us where in that rubble pile apartment 902 was. And we knew that 2 people were in there, and we knew that one of them slept on the couch, and it was an orange couch. So, you know, all of those things combined led us to an opportunity to more effectively locate buried victims. So that's where we're at right now with technology, Dusty.
Thank you, Fred. And you know, all of those are unfortunate circumstances, but I just felt a wave come over me of that. Nice to have actually had some success. So it's awesome that we're still pursuing that. And I know that, as we discussed, not only have you gone through and developed better technologies, but along the way you've probably learned some things about some technologies that weren't as helpful, or some approaches that folks had that seemed like perhaps a great idea on paper, but had some challenges of their own. And so for folks that are listening to kind of gain the benefit of our lessons learned, could you talk about some of those approaches that were either explored that didn't work and or ones that were proposed and weren't feasible?
For Dusty, I think from my own experience with this over many years, a lot of the effort has been focused on robotics. And I think some of the maneuverability and some of the ability for robotic applications to penetrate deep into collapse voids, again, depending on the type of construction and the type of collapse, we've had probably some of our biggest challenges along those lines. And I think a good example of this, what led us to Dennis again and S&T, was at Surfside. There were some suggestions that some technology that was in prototype form might be able to help us at that particular collapse. And we certainly were game to try that, and we did. But because of that pancake collapse, and I think for the audience, it'd be probably a good illustration to think about this for a moment. So the room I'm in now has an 8-foot high ceiling, as most of the apartments did in that condominium complex in Surfside. But what we were dealing with was 8 to 12 inches of that same space just compressed down, that 8-foot compressed into 8 or 12 inches. So the sofa, the refrigerator, the dishwasher, all the furniture, everything was in this, really, really small, narrow space. And robotics simply were not able to penetrate that and move through it and give us the information we needed, whether it would be by camera. Certainly they could do some hazardous materials assessments for us and give us an image, but really the image wasn't helpful because of the context of the collapsed void space being so small and so, narrow.
Not even consistently. It was, it'd be one thing if it was even consistent across, but there was more than that, as we saw in those demonstrated in those pictures. So thank you. One of the things that I think is always helpful is that, as a non-participating member of USAR and part of the public or a small business, we want to help, but sometimes it's tricky to figure out, okay, where do we start in trying to determine what the resources are that we can learn more about these programs or problems. We're doing this because we want folks to be able to ask the questions that they have specifically, but if they're starting from an earlier block, let's say, in the learning curve of what those challenges are, can you provide some resources they may be able to start with?
For Dusty, I think for me, and this goes back almost 20 years, but I think a comprehensive study, the title was, is Urban Search and Rescue Technology Needs, Identification of Needs. This was published in 2004. This was a joint project between the Department of Homeland Security, FEMA, and the Department of Justice, and it was prepared by the Savannah River National Laboratory. And even though it's somewhat dated by our current standards, all of the information is relevant today. The findings, the observations, the scenarios that were set up to test different applications, very detailed report that goes over exactly what the test sites look like, what was tested, what the metrics were, how that was measured. I think for somebody that doesn't really have a familiarity with, this type of work or this type of technology would be a great baseline for them to just take a look at and really get an overview of a lot of different processes related to how this works.
Yes, and I think the slide that we're showing now is some of the requirements that were elaborated on perhaps in the RFI. Are there any of these that you think are worthy of additional discussion or note?
Yeah, I think, again, Dusty, from my perspective, we talk about this a lot with our subject matter experts in the technical search field for USAR. And I think one of them said to me a little while ago, look, Fred, we don't care if they burrow, crawl, fly, or hop over or through the most difficult rubble test terrain. We just want an innovative way to negotiate those obstacles and get the information back to us as quickly as we can. So I think that's a pretty good frame of reference from a dumb firefighter like me is, it's important that, we think we know what we're looking for, but there's a lot smarter people out there on this webinar that maybe will get an idea. And the points that are listed up here right now on the slide came directly from that report from Savannah River National Labs. but that's what we're looking for. But I think, Dusty, an important point here is not to be limited by, I'll go to the second point, and I was talking about this with, one of our section chiefs, the operations section chief at FEMA you saw earlier, Dean Scott. Be small enough or flexible in size to weave through or between crevices, centimeters to inches, and other similar obstacles. But we didn't want to limit it to that because maybe there's something else out there that could help us. I know, in Haiti, we looked at some ground penetrating radar and some LIDAR and some other applications that were being developed at that time, but, not specifically for USAR, but just were brought over into that event. So I don't know if Dennis has anything related to that. And the point I want to make here is for people's imagination to just, I don't want to say run wild, but just to be creative and think we don't want to be limited. Maybe somebody out there has something that checks the box in 4 or 5 of these, but doesn't check the box in all of them. It still might be an incredibly valuable step forward for us. So I would leave it to that and maybe open it up to Dennis to see if he has any thoughts on that.
Thanks, Fred. No, I think you hit all of the salient points there. I think probably most importantly is nothing's off the table here. I think some of the other work that we did, a couple months ago, I would say, we did what we call a tech scouting report where we actually surveyed and did a little bit of research on our own to see whether or not if there were any solutions out there. And I think, when we talk about these pancake buildings, that's probably the area most important that we're looking to resolve some of these issues with. And, the ability to, slither, almost like a snake, through all that rubble and be able to find any human remains or any bodies that might be still alive, and then be able to, if possible, to some degree, maybe be able to inflate itself. We saw some earlier work done where this snake-like apparatus was able to inflate itself and actually move some of that rubble in order to gain a little more insight into what exactly the search and rescue team might be dealing with in terms of, that collapsed structure and how it's really impacting that person that might be trapped.
Yeah, thanks, Dennis. Hey, Dusty, one other thought here. I don't want to dissuade people with the bottom bullet, the final product cost between 10,000 and 25,000. I mean, that's a range of, and I guess, there's other considerations here for manufacturing and marketing and, what is the target audience for that, which I think we'll get into in a little bit, but I wouldn't want to make that the limiting factor for the audience. Thanks.
I think it's great the way you poise that in terms of, the sky's the limit kind of thing, because this is a problem we haven't figured out how to solve, obviously, and our ideas thus far have been somewhat effective, but not the ultimate goal. So, and the purpose, in case folks kind of read what I was asking before, and you've done a wonderful job at articulating, one of the reasons we're asking what has been looked at before is if you have an idea that's similar, well, here's the challenges we had with that type of approach. And doesn't mean your maybe idea doesn't solve those. So yeah, we're not saying that if there's an idea you have, come to the table. We'd love to hear about it. So thank you, Fred. I think it's great that you guys are looking openly for these solutions. And yes, you're correct. The next question, I think one of the tricks with trying to, we're DHS and we're, Dennis and I at S&T and you're at FEMA, sometimes is there can be a misunderstanding between who is the end user and who's going to buy this product and what are the challenges to getting to that commercial state of an end product and an end user and somebody and knowing who's going to purchase it. So can you help speak to kind of who those folks are so they can understand the chain of what has to happen and what the challenges may be?
Sure, Dusty, I can probably relate this through some experience I had in Philadelphia as an officer in Rescue 1 when we would come up with an idea and then we would I wouldn't say pitch it, but we would talk to some people who are a lot smarter than us, and they would help us develop it. And so out of that, baseline idea, and then initial testing and thought processes and different variations of a tool, we would eventually come up with something. And then in 2 cases, somebody would bring that to market. They would further refine it and develop it. So I would say, going back to the baseline question here of audience, a couple approaches. So certainly with the program that I'm with now, that program is looked at as somewhat of a gold standard in the response community. So equipment that is developed with the input of subject matter experts in certain technical fields at FEMA USAR eventually could find its way down to the local level, first responders, the fire departments, technical rescue teams, state urban search and rescue teams. So a couple of different ways to approach that, but definitely I think the market in the fire service side, and then also in the parallel law enforcement and military side, there's definitely a potential large market for the right technology and the right tool. I wouldn't limit it just to building collapse operations. I happen to serve at the World Trade Center as the operations chief for FEMA's USAR system, and we had the opportunity to field test some classified, at that time, some very classified technology, talking about just about what we're talking about now. How can we find people buried in this type of collapse? So I would say that, the end users could be a broader audience than certainly urban search and rescue and first responders. Again, depending on the technology and depending on the cost and the final application. Thanks.
Thank you. And Dennis, I didn't know if you had anything wanted to add.
Yeah, Dusty, I would also add to what Fred just said, that this particular product would probably have a international flavor to it as well. These types of events happen all over the world, right? So, and a lot of these search and rescue teams come in from all over the world to help out in other countries. So this would definitely be an international type product, I would think.
And we did have one person ask that question as one of the entered when they registered and asked about the international market for this. And I know that DHS on almost all of their programs are looking to where we can work with and leverage what's available internationally and vice versa. So that's fantastic.
Hey, Dusty, along those lines, and just to build on Dennis's comment, so 2 of our 28 teams also have concurrent agreements with USAID, and they go internationally for those events that Dennis was alluding to, earthquakes and wherever, Nepal or Haiti or Armenia. So we are connected to them. There is, it's a small circle, obviously, of professional relationships, but, we do deal with the international teams on a regular basis, and their certifying authority, the International Search and Rescue Advisory Group, which really is an arm of the United Nations. So there is definitely an international interest in this.
Great, and I think that it's good information for folks that aren't necessarily as aware of the space to know that exists. So thank you. I think that's great information. So those were the questions I had for you fine gentlemen. I'm going to let folks know that we're going to be moving on to the Q&A part where we're going to take questions from the audience. While I do that, we wanted to make sure that you had the ability to get to the resources that Fred and Dennis were discussing during this event. So we will be putting these links into the chat. So if you're watching this live, don't worry, you don't have to scramble to write down that whole thing and then try to read your chicken scratch later if you're like I am. So you can just do a copy and paste. But while we figured we'd want to look at those while we were getting ready for the Q&A. And I do know that we do have some questions already from folks. And so thank you very much. So the first question that I wanted to ask was, does the technology have to take into account environmental factors for USAR teams? Feel free, Dennis or Fred, either one.
Yeah, Dusty, I'll answer that just from the user's perspective, right? So the conditions that we find in these collapses are certainly driven, or strategy and tactics are driven by environmental conditions. So From a user's perspective, I would say yes, but I wouldn't want to make that too much of a limiting factor, right? So we would like something that would be able to operate in really adverse and challenging conditions when it comes to atmosphere and, or hazmat maybe. But again, we want to just keep this as open and broad as possible. Potentially a limiting factor, but not a showstopper.
Okay, thank you. Next question. Is there an interest in a product to assist removal / transport of victim? So I think that might go outside the parameters of this, but would you like to respond to that question?
Yeah, I mean, the system was designed for search and rescue, right? Not body recovery, but we do a fair amount of that also. So there would definitely be some interest from my perspective in that. And Dennis, I don't know if you had any comments on that, but again, Dusty, from the end user, definitely.
I would agree with that. Again, I think, in this particular case, I wouldn't take anything off the table. I wouldn't, in other words, nothing's limited here.
The one limitation is to respond to the RFI, you have to be a previous SBIR awardee. Other than that, it's open. So thank you. All right, next one. In this opportunity, is the priority in locating individuals with vital signals or all persons? What about other assets other than humans?
So obviously the highest priority would be live survivors, right? With vital signs that you could somehow detect that. But again, going to what our reality is, the removal of the deceased, that's part of it too. So it's, I would say in very general terms, Dusty, we're interested in all of it. Locating buried victims is the priority.
Thank you.
Oh, Custy, I think the second part of that question was just anything else, and I'm not quite sure what the question was referring to, but maybe like pets. We do get a lot of interest in pets and detecting, removing them. So that would certainly be part of this, and I think that would be a parallel to it.
Yeah, I'd be right there with you. I'd be, yes, get victims out and as much as possible. All right, so somebody asked, can you write the name of the resource you just shared? And so I think we took care of that one, but if for some reason the list that we provided did not include something that you thought might have been a resource, we'll be looking at something later and you'll find out how to do follow-up questions, and or you can put it into the chat here now. But if we don't get to something, we'll give you ideas on how to get information. Next question. There is the use of ground penetrating radar, yes. I think that's correct. So I'm assuming they're asking about the use of ground penetrating radar, and maybe you can speak to why that is not necessarily something that gives us all the capabilities we're looking for.
No, I think, again, we have pretty limited experience with this, Dusty. I think it was utilized, at least for me, for the first time that I saw utilized was in Haiti. So it definitely has application. And again, I wouldn't narrow the potential here. I wouldn't narrow it out at all. I don't have a lot more to say, but Dennis, maybe you have a little bit more from the S&T perspective on that.
Dennis is maybe having some technical challenges. I know he's in the offsite space today. So is there other, for instance, the technology that was used in Haiti was not able to provide the desired results for Surfside? Is there any additional information other than what we've shared that may be informative for folks looking at that technology?
Let me go to Dean Scott. Dean is the operations chief of the Urban Search and Rescue Branch. Hey, Dean, I know you weren't planning on this, but do we have anything?
We can do a phone a friend.
Yeah. I don't recall from our old technical search work group having anything specifically on that. I know we've looked at a lot of different things, but as far as like a formal summary report, I can't recall anything along those lines. Do you?
Oh, not off the top of my head, boss. We can go back and check and see what we can come up with, but not right at the tip of our fingers.
Yeah, Dusty, we'll do a little bit of digging with our subject matter experts and see what we have on that, and happy to pass that on to the person who posed the question.
Okay, great. Thank you.
And hey, Dusty, and I think the only thing that we have that we've done in the past in this space was probably Finder, where that actually utilized microwave radar to detect small movements from breathing and heartbeats.
Okay.
Other than that, I don't think there's any other research that we've done in this area.
Okay, good to know. Thank you. All right. Next question. To compare some of these points to the current flexible cameras, what is the distance that camera can be buried, weaved into the pile? How long are they, inches or feet? You want me to reread that, or did you get it?
No, I think I have it, Dusty. So it's an adjustable scope, a bore scope that can be extended or contracted. I think maybe the ultimate extension is 6 to 8 feet for that. And then, it can be compressed as needed, depending on the size of the space. So obviously the key is to get the camera in there so you can get as much of an assessment as possible of a particular void space.
And is it flexible as in terms of trying to navigate the pile, or is it a straight shot?
It's the scope itself, the bore scope itself is more of a straight, rigid piece, but there is some flexibility on the end of it with the camera, a little bit.
Okay. All right.
Hey, Dusty, just let me go back to that a minute too. So in the past, we have field tested some cameras that were very flexible, almost like Dennis had described before, like snakes, very narrow diameter or narrow circumference camera that could just be pushed through. But the problem is when they get to a certain point in a collapse and they hit a hard stop, they can't go any further. They're just too flexible to move, to push through. So it's, I just make people aware that 20 some years ago, we were testing a similar application like that.
Yeah, I think that's good to know, because again, in your mind, you're thinking, well, just do this, right? And you guys, like you said, when you were back in the field for the firemen, you were saying, hey, what about this? And that I think speaks to this next question, which I think we've covered, but we'll ask it anyway. Are you only looking for systems that crawl through rubble, robots, or interested in remote sensors also that can still locate survivors? So I think
I would give the the easy answer here, that we're looking for everything. Whatever somebody creative could come up with, we're interested in all of it.
So this one goes to one of the parameters on the technology concept you were just thinking about or talking about. For snake-like sensors, what would be an expected maximum diameter of the snake be for it to be useful?
I don't know. So if you go back, can you put one of the slides up, Dusty? Can we push one of those slides up from Surfside or Haiti?
Yes, the one with 2 or the one with 3?
Either or, I think we can.
Okay. Can we get the slide back up, please? Thank you.
So, just going back to what I was talking about with the technical search cameras, we usually look at a 2-inch diameter opening, but certainly it could be smaller, it could maybe even be a little bit larger, just dependent on the specific collapse type. I mean, there might be an opportunity to get something down pretty far that was wider than that. So I don't know if that's, helpful in the answer to the person who asked the question, but I think if you take a look at, some of the rubble here, just take a look at the one to the right and just see some of the opportunities, I'll call them, the very narrow openings where you might be able to get something down in and maybe be fortunate enough to get a pocket and go all the way down into a void space and locate a buried victim. Take a look at that, and I think that gives you some perspective of scale.
Yeah, it does seem like there's a high likelihood of running into a block there, but that's, again, maybe that's provides also some information. So, all right, I won't speak to the requirements. I'm not the expert. All right. Oh, sorry. I'm having a technical challenge here. All right.
Hey, Dusty, I would add that, part of this research might be to help identify some of those trade-offs between, flexibility and reliability, issues like that. That might be more determined through maybe the phase one of the research. I mean, some of this stuff we don't know the answers to, because I think what we're looking for is something very sophisticated. It's able to crawl through a very small space, but have the ability to maybe move large pieces of rubble. So,
or not even crawl if there's another, again, another way
oh
to.
yeah, exactly. Yeah. I mean, it's pretty complicated when you think about it. So that's why I think, some of the answers that Fred and I are giving are like, there's nothing off the table. I mean, I think everything's open.
It's what these small
for
businesses do best, be innovative.
absolutely, exactly.
There's several questions related to the SBIR program that I'll try to hit broadly and quickly here. The SBIR program is a it's a program to leverage US companies, and it also provides that economic benefit to us being able to help fund and promote US small businesses. So it is limited to US small businesses, and this opportunity is we're looking for how we're leveraging those technologies already started at another federal agency, for which we can take advantage of the time and the money the federal government's already put into technology development for this. So that's what we're referencing today for some of the folks that may have joined a little bit later. Last one says, have you ever looked at, oh, not last one. Have you ever looked at cellular detection, not triangulation from a tower, but the ability to find that signature from a cell phone on site and accurately? Most of us have our phones near our person.
So Dusty, the answer to that question is yes. Sometimes in our work, we cross over into the law enforcement side of things on how that might have to be done. But we definitely have looked at that technology and utilized it, or other parties have utilized that in our collapse operations in the past. But ideas related to that. Yeah, I was just going to say, just open to new ideas.
This one references Finder, but I think we already talked about that in terms of tested any through wall radars. Oops. So referencing question above, reaching out to FEMA experience outside FEMA using ultra wideband STTW since through wall radar systems. Did we answer that already? Yeah,
I don't have a lot on that one, Dusty. Maybe Dennis would. I don't know, again, what some of the things that were looked at over the years with S&T. But we don't have a lot on that. And again, I can go back with Dean and we can check and see with our subject matter experts what we have for, I'll call them, alternative methodologies that we just don't employ in our equipment cache right now. But again, we've been looking at everything for many years. I just don't have a lot on that.
Yeah, and it's hard to be able to speak to everything we've done over these last 20 years with, details on all of it. And then there's what do you mean by snake-like apparatus? Please share more details spec. What is your ideal state? So I think we don't know what the ideal state is. That's why we're coming out. But do you want to, I guess, speak to snake-like apparatus?
Dusty, there's again, it's, probably an easy mental image of a snake slithering, right? Depending on how it's motorized or what it can do. Usually the idea would be to have a camera on the end of it and have it be able to negotiate rubble to get to a certain point in a collapse void. I don't know that we have any pictures of one. There's a lot of prototypes out there. And again, I don't want to put Dennis on the spot, but I'll go back to him. I'm not quite sure what S&T has looked at over the years. That might have been something that was considered. And again, we're happy to search our archives too. I remember probably 13, 14 years ago, we had a pretty big seminar with just robotics, and you know, some of those snake-like technology pieces were there. Dennis?
Yeah.
Yeah, I would say this is all relatively new, so we don't, and I'll go back and check, but I don't believe we've done anything in this area in the past. But I'll double check.
So, and again, please forgive my non-technical or non-operational experience in this area, but so I think one of the things that may be challenging is with a snake-like is it still may need to see beyond the space it can access, correct? Because somebody could be in an enclosed space that has no or figure out how to move what it's encountering. Or am I not? Feel free to tell me.
No, Dusty, I think I understand what you're envisioning here. And yeah, no, that's one of the challenges. Like, you know, how do we overcome that and get a piece of equipment or a piece of technology that will give us that result? Again, we'll go back and look, and I know you're capturing all the questions here in the chat, but we'll definitely look and see what we have and see if we can provide some examples of what's out there and what we might have looked at in the past.
Yep. So I'm going to say, I think we could get questions all day on this. So I think we're going to have to cut it off at one point. But if we can pull up the information for how folks can get to this opportunity. So the RFI has been posted on sam.gov. We created Bitly to try to make it easier for folks to be able to find. White paper submissions are due March 16th, 2022 at 11:59 Eastern Standard Time. And in that posting, there is information on how you can submit questions. So what we've discussed today is not the only way to be able to find out more information. And the email address below, stsbir.program@hq.dhs.gov is one of the places you can email. And we will make sure that my office works with the smart folks. Speaking of which, Fred and Dennis, I want to thank you very much for joining us today. I think the information that we've been able to share, as you can tell from the questions we received, there's folks that have some ideas and potentially some solutions that they'd like to submit to us. So thank you very much for joining us and helping us to get this information out so we can hopefully get some solutions and some ideas to you guys.
Thanks, Dusty.
Thanks, Dennis.
Thank you.
All right, and please feel free to follow us on social media to make sure you're aware of upcoming events and other potential opportunities. And you can maybe catch us at our next Deconstructing SBIR for a different subject. So thank you, everybody. I hope you have a fabulous Tuesday, and see you later.